Today's talk will be about pesticides and water quality, presented by Karey Windbiel-Rojas. Karey is the Associate Director for Urban and Community IPM and Area Urban IPM Advisor for Yolo, Solano, and Sacramento counties. As Associate Director, Karey provides leadership and coordinates communication and educational efforts to address pest issues around homes, structures, landscapes, gardens, schools, and public areas.
Right. Thank you for joining us today, everyone. So as Belinda said, today we will be talking about pesticides and water quality and how to keep pesticides out of our waterways. And I'll talk about how we do that and how we can consider integrated pest management while we are looking at our pest issues. So just to start off with, pesticides have been found in our water in many locations throughout the United States. There are many different statewide and local and regional water quality monitoring programs in California, but also throughout the country. And they have identified pesticides as some of the main contributing factors of negatively affecting water quality. And the contamination of our waterways, not just in urban areas, but as they flow through our environment, can result in damage to aquatic organisms and to the environment and the ecosystem overall. And so one of the things we want to do is make sure that people understand using pesticides and how that does impact our water, because a lot of folks don't have training on pesticide use and don't understand the consequences of pesticides getting into the water and affecting our environment. It is possible to use pesticides and still protect water quality if we handle the pesticides correctly. And so today we'll talk about several tools in understanding pesticides and how they can affect our water and still protect our water if we choose to use them. Now, I do want to preface that we are talking about integrated pest management as well. And so this is just if a person chooses to use pesticides. Towards the end, we'll talk about IPM and also not using pesticides to manage your pests. But in this presentation, I'll be talking about the different ways pesticides can easily enter our waterways from our residential use. And we'll also talk about the properties of pesticides and how they can be influenced by the soil, the type of pesticide and active ingredient, and the makeup of the pesticides, and also how weather impacts their movement. We will end with some basic practices that you can do both in landscape design and integrated pest management to reduce the potential for pesticides to get into our water and impact our clean water. So first, let's discuss how pesticides do get into our water and ways that we might be considering reducing that. So there are many different ways pesticides can get into our water bodies, either through irrigation that we, our sprinklers or hand irrigation, and also through rainfall and other natural water systems. Pesticides that are applied to our landscapes can easily be washed into our storm drains, which lead to our waterways, because the pesticide can run off carried by water or soil, as we'll talk about. And eventually this water will end up in our creeks, rivers, or oceans. A lot of people think that our storm drains go to a water treatment plant and that the water gets cleaned up and all contaminants, including pesticides, get removed. And then what comes out is clean H2O, but that's not actually the case. So we do want to try and educate folks on the water system and also ways they can reduce the potential for pesticides getting to our water bodies. So runoff can move pesticides off-site, off the area of application. And so runoff is excess water that is removed from the landscape or moved from the landscape. We sometimes call that urban drool as well. But runoff is just, the water moving off site where it's intended to be. And so there are many contributing factors to how water will run off an area, a landscape, or a lawn. And this could include the slope of the area, right? There's a slope that naturally the water is going to flow away from, but also soil texture and how well it holds onto that water, compaction of the soil, and the amount of vegetation that might be there to hold onto the water. Also, soil that is saturated can't take in any more water. And so if it's already saturated, the excess water will run off and can carry pesticides and other contaminants into our storm drains and water bodies. The amount of irrigation that we put on is going to influence the potential for runoff, and also any rainfall that's expected or unexpected, and how that interfaces with our irrigation systems. And then there's, of course, the pesticide characteristics and pesticides that are more water soluble or adhering to soil and being carried by water offsite. So I'll get into some of those things as we continue on. So irrigation that we set up, either sprinkler irrigation is a big contributor to runoff, as the irrigation, the spray nozzles might overspray and already be not directed at the target site for the sprinkler. And that washes materials off of paved surfaces, which may contain pesticides or fertilizers or other contaminants. We see that in dry, arid climates, summer runoff is primarily the result of this overspray or over irrigation by our sprinkler systems because it's not raining, right? So it's the irrigation in the summer that's going to be carrying off the pesticides and other contaminants. So there's also rain and excessive irrigation that can cause a pesticide application to leach into the ground. So if there is a lot of water and there's no movement, it can cause pesticides to leach into the soil and no longer be effective against the pest that the pesticide was put out for. Here is a picture showing some dyed water that was put onto a soil to really illustrate the concept of leaching. So that blue color is dye that was applied to the soil surface, and then excess water was put on, and it just shows you how that the contaminant can leach through various types of soil and get down into water tables and further down into the soil, which can cause further environmental contamination. So we want to try and avoid leaching of pesticides into our water table and the environment. Pesticides can also move with soil that is moved off of site. So we call that erosion. So erosion is the process by which soil will move from the landscape due to flowing water. Sometimes this is because of irrigation equipment not being set the right way and having that overspray. Sometimes it's due to the slope, as I mentioned earlier, that the soil is going to just naturally sort of dribble off an area. Sometimes it's over irrigation, where there's just too much water, the soil's saturated, it's left on too long, and so those adjustments could be made to make sure that the water stays in place. And then erosion can also be the cause of natural weather issues, such as excessive rainfall or snowmelt. The speed and amount of runoff determine how much erosion we're going to see. When erosion occurs, pesticides can become attached. As I mentioned, some pesticides are more water soluble, so they flow with the water, and other pesticides actually attach or adsorb to soil particles, and they can move that way. So there's different kinds of pesticide properties that I'll talk about shortly, and how they will move off of site, either with soil or water, is going to be important to understanding how we can keep pesticides on site and not having runoff or this kind of erosion. Another factor in pesticide movement will include pesticides applied directly to paved surfaces. So cracks or curbs, crevices, and sidewalks or parking lots. And so these paved surfaces are more slick, and there's no vegetation to hold onto the pesticide. And so through irrigation or rain, the pesticides can very easily be washed off and end up in our storm drains and into our water bodies. And so there are various types of hardscapes that we can use that will catch the pesticides or limit their movement. And that could include, decomposed granite or more like flagstones in between some vegetated areas that can keep the water from moving off. But when there's none of that, then the slick surface just allows the pesticides to, quickly move off site with any kind of water. Spray applications can easily drift into water by many different means, but small droplets can drift from the area where they are applied into our water bodies, especially when a water body is right next to the area. So this is a beautiful home in Washington, but you can see that the lawn and some of the landscape plants are right up into this water, which is a very well-used recreation site. And so having a spray application right up into the water, there's going to be, of course, natural spray drift and maybe some leaching that gets into the water. So if we can create what's called a buffer zone or a no spray zone, where the pesticide is not applied for a certain distance before that water, it will reduce both the spray drift and the runoff or leaching that can get into the water body and contaminate it. Another reason for pesticides ending up in our waterways is improper handling of the pesticide at the time of application, during application, and after application. So one of the most likely pathways for pesticides getting into our water is when we misapply it. So we spray too close to a water body or a storm drain or a landscape drain, and overspraying, also getting it on the sidewalk. And this could be a spray, or it could be a granule or a dust. Spilling of a pesticide can also get easily into our waterways and contaminate the water. But there's also improper storage. Maybe the bottle leaks and it finds its way into water, or maybe if they're kept outside, the rain can wash off any pesticide on the outside of the container. So improper storage is really important to consider. And then also what we call mixing and loading, when you are maybe diluting a pesticide and putting it into a sprayer. Mishaps, mishandling, spills, leaks, all of that can contribute to pesticides getting in the water. And then, of course, the improper disposal. As I said, some folks think that the water that goes in our storm drains will get cleaned up in water treatment plants, and so they may dump the water down drains. This could be outdoor drains or indoor drains, and so we never want to do that. We want to make sure that pesticides are disposed properly through the household hazardous waste disposal, or by using them up and then rinsing the containers at the site of application. So I did mention weather a little bit, but weather conditions can definitely impact pesticide movement and can greatly impact the movement away from the site of application. So it's important to know how weather can affect this movement. Pesticides that are applied before an expected rain event should be reconsidered, because rain will easily wash that pesticide off, which wastes the material, and it also wastes money, and then you're not going to have the good pest control that you might want. So making sure that you know when a rain event is going to occur, so that you delay your application, or consider how much rain might be expected. But you definitely don't want to apply pesticides when this says heavy rainfall, but I would say any rainfall is expected within 48 hours on either side of the rain event. Products that enter the storm drain, of course, carried by this rain, can contaminate our water, and we want to try and avoid that when possible. Wind is another environmental factor, weather event that can blow pesticides into nearby waterways. Wind can blow pesticide spray droplets from the intended application site into nearby waterways, or even to desirable plants. And so we want to make sure that any pesticide application is done when there's no or little wind. And that's a spray application, but also dust or granular application can also be carried by wind, or can be attached to the soil, and then the soil gets blown into our water bodies. So wind is an important environmental consideration as well. For high temperatures and low humidity, this increases the volatility, or how a pesticide might get into the air through vapor. And so during some times of the year, in certain areas, we're going to have higher temperature and various levels of humidity. So keeping that as a consideration when using pesticides. And on pesticide labels, a lot of the labels will say do not use above a certain temperature. That might be both for environmental, but also for using on a plant. You don't want to burn a plant by applying a pesticide when the temperature's really high. Another important environmental factor is the characteristics of the soil, and how pesticide properties can influence the off-site movement based on the soil properties. So the soil texture and structure helps a pesticide either move through with water or adsorb to it. So there's different moisture retention characteristics of different kinds of soil. So you want to try and understand what soil you have, and how well the water might move through, and if it's possibly going to leach out pesticides, and also the water holding capacity of your soil. Soils that are high in clay or organic matter may bind pesticides more tightly. And I'm not going to get into too much soil discussion today, but organic matter does influence the soil structure and water holding capacity. And these characteristics can influence the water holding capacity and the pesticide persistence in the soil. And so, we want to try and choose pesticides that are not going to persist in the soil for very long. And those are going to be better for the environment, but also, again, those rain events that may carry any kind of highly residual pesticides into our water bodies and non-target areas. So more on the soil depth and leaching, but soil is made up of different layers, and these are called horizons. And so there's a lot of organic matter that's usually in the top horizon. And as you get deeper, there's a different soil structure, and some pesticides can be retained for longer times in these lower layers. And, this can definitely affect soil organisms and later any kind of leaching or offsite movement. So there was another slide that seems to be missing. Okay. Certain pesticide properties are more conducive to offsite movement. There's many different pesticide active ingredients that are available for residential use, and they have many different kinds of properties that are important to consider. And so when purchasing a pesticide, knowing that what the active ingredient is and what is going to be more effective on the pest is important, but we also want to consider how it's going to behave in the environment. The formulation of that pesticide is also important, and other factors when you're considering the safe use and application of a pesticide. And then also what's in the pesticide. There can be stabilizers and surfactants and other things that affect water or soil. And a lot of pesticides that are liquid contain a great deal of water already, but some of these can move off-site because of the properties of these pesticides. So we do have other webinars that talk about pesticides and their safe use. So I know I'm not giving a full picture of pesticides and understanding active ingredients and properties, but towards the end of today, we'll talk about resources and where you can find some of this other information. I do want to note that, we talk about pesticides, and what we are really talking about are the manufactured formulated pesticides. We're not talking about home use remedies, homemade pesticides. So we're talking about pesticides that we know what's in it, we know the properties, because some of the home remedies, we haven't studied what they do in the environment. So what we're talking about here are the manufactured products. So pesticides, when they do get into the environment, they are going to be degraded by microorganisms, also by sunlight and other chemical processes in the soil. And so all pesticides will be broken down at various levels depending on what kind of pesticide it is. Soil temperature is important, and also soil fertility and pH and lots of different properties within the environment help a pesticide break down. And many organisms will also contribute to breaking down that pesticide. But there is a wide variety of the kinds of pesticide persistence in the soil and how quickly these chemical reactions do occur. And that's something to consider as well, is how quickly is the microbial degradation going to break down these pesticides, and how long will it persist in the environment. Some of the soil conditions that favor this reproduction is going to be important for the persistence of the pesticide and later potential for runoff and leaching. And as I mentioned, there's different soil temperatures and pH and that adsorption, right? The pesticide adhering to the soil particles. And when the pesticides do break down in the water, which is called hydrolysis, that's going to be a factor in its potential for later contamination. So this is a chart that you don't need to study, but it's showing how long certain pesticides remain active before they break down by these chemical processes and hydrolysis and microorganisms. And so there is definitely variation in how quickly a pesticide will break down in the environment. All right, so when we are considering our pests and how to control them, we want to consider integrated pest management. Integrated pest management, or IPM, involves using a combination of complementary practices or methods to solve our pest problems. So this whole time I've been talking about pesticides and soil and water and contamination, and we don't necessarily have to use pesticides. There are other methods for pest control. And so I'm just briefly going to talk about IPM, and then we'll move back to pesticides again. But in integrated pest management, we want to monitor for our pest problems. A lot of times people think they have a pest or they saw some damage, and so they just grab the pesticide and start to spray. And so another big important factor in reducing pesticide contamination in our waters, soils, and environment is to make sure we do have a pest, and that it's not some abiotic or non-living factor, and that the pest might still be there. So we want to use IPM, which involves monitoring and detecting and assessing our pest issue, identifying that pest and finding out about it. Maybe it's not even there anymore. Maybe it's moved on. And so any kind of pesticide application is not going to be effective. And then we want to use the scientific ecosystem-based information that we know to manage that pest once we've determined that there's something we need to do. And that involves the combination of various practices to hopefully get the long-term management. So identifying the pest is going to be very important. As I said, sometimes we see damage, and so this notion of a perceived pest, something damaged my plant and I must control it, right? That's kind of how we think about things. But if you see this picture, and some of you may recognize this picture, this damage, if you will, as something that's actually an insect, but not a pest. This plant damage is caused by leafcutter bees, which are pollinators and not really considered a pest. But yes, it chewed on the leaf, and leafcutter bees really like to take those little half moon slices out of our rose bushes. But is it something that you need to control? So there's a lot of questions before any pesticide is applied or any action is taken. Is the pest a pest? Is there an issue? Do I need to do something? Is it still there? If I apply a pesticide, am I going to, reduce the population or, fix the problem? And can you tolerate the damage? Is there so much damage on your roses that, wow, I really need to control these bees, or can you accept it? And then are there other non-chemical methods that we can employ that are going to get that kind of control that you want without using pesticides? And so this is where we use the integrated pest management concept, where I talked about monitoring and also pest ID. But once you determine that there's a pest problem that you need to address, then we use these components, these features of IPM. Is there something you can do to prevent the pest from becoming an issue or increasing in getting to a really high population? Are there different kinds of control measures, things that you can adjust in the environment to reduce the favorability of the pest over your plant or your home? Are there physical or mechanical controls that you can use to either trim off the infested part or block the pest, or other kinds of measures? There's a lot of biological control that will naturally control pests for us. But when these things don't work and you've already tried them and you move to chemical control, that's where we need to consider the pesticides and the fate in the environment. So we do have a whole webinar on integrated pest management and the different examples of IPM. So that's all I will say about IPM sort of for now. and we're going to move back to talking about pesticides and keeping pesticides out of our water. So if you've tried all those non-chemical tools and nothing is working, or it's just not getting to the level of control that you are looking for your already identified pest, then considering a pesticide may be warranted. And so when considering a pesticide, there's all the application considerations like, you know, weather and soil properties and pesticide properties. But you also want to make sure that you're choosing a pesticide that's effective against the target pest that you've already identified, and considering these environmental impacts. How quickly does it break down in the environment, and could it affect our water quality? What about some of the non-target organisms like people, pets, and some of these biological control agents? What might be the impact on bees and these other, you know, sort of good bugs? And then how easy is it for you to use the pesticide product? Knowing that there may be environmental consequences, and you're reading the pesticide label, how easy is it for you to understand what the label is saying on, you know, how to dilute and how to spray? Is it the you know, right type of material? Do you need just a spray bottle, or do you need a larger quantity? And making sure you understand how to dispose of it correctly. So lots of considerations when determining to use a pesticide. So I did talk about environmental conditions. So just to sort of continue on, checking the rain and making sure you're not spraying on a windy day or when there might be a lot of fog and what's known as an inversion, and those high temperatures and humidity. So many considerations after you've chosen to use a pesticide so that you can have the pesticides be applied where you need it and stay where you need it. And when deciding to use a pesticide and looking for the best way to make sure the material stays on site, surveying or looking at your application site and considering, well, do I have a slope, and is the water going to carry it off? You know, what's sort of downstream? You can see this top picture. You know, there's a very low gutter here, and any kind of runoff is going to carry any pesticide application that's come off of your landscape down to the storm drains. And so considering your slope and adjusting how you apply to reduce that runoff. And so also soil, I mentioned compacted soil. Is the soil so compact that the water isn't going to seep in carrying that pesticide? Is it just going to run right off? And then also how many hard surfaces are there around that might also carry that water containing the pesticide? And then you definitely want to avoid spraying over the storm drain if there's a storm drain or other kind of drain in the landscape, because that is going to directly carry that pesticide into the waterways. Choosing your pesticide right, you're going to choose the least hazardous material for the environment and the non-targets, but the most effective product for your target pest. And reading the label again and looking at the environmental precautions, and then following the label rate and the right kind of application technique. And then the best way to have your pesticide remain viable and make sure you're getting the right quantity out is to calibrate your spray equipment. How much comes out of that spray nozzle, and how long do you remain over an area? How quickly do you walk? And then maintaining your equipment so that your nozzles are delivering the right amount. Maybe you have a broken nozzle. Is there a leak in the hose? All the things that you might consider to make sure your spray equipment is in the best shape possible. And then, of course, wearing your personal protective equipment to protect yourself against the pesticide exposure. Irrigation and landscape design. So we're talking about choosing pesticides and using them correctly, but also there's the design of your landscape. How is it already designed? And are there things that you can do to change your irrigation or your landscape design to better keep the pesticides in place and reduce that runoff? So managing your irrigation, either system and how much irrigation is put out at one time, and also the irrigation design to make sure that those sprinklers are not overspraying and creating the runoff, and that you have uniform coverage in the area that you need. So this may require that you adjust sprinkler heads so that water is applied only to vegetation and not to those hardscapes. And there's also the concept of these buffer zones shown in the bottom picture, where you have a buffer between an area that you may likely spray a pesticide and the hardscapes and the storm drains and gutters on the other side. So is there an area that can sort of catch any potential runoff before it gets off-site? And that's going to be really important for reducing any potential for runoff. You can also install things like rain gardens to allow runoff to soak into the ground, but being mindful of, you know, the problem with leaching in different sort of soils. But there's all kinds of ideas in when you are choosing to use pesticides that you can change a landscape design and irrigation system to make sure that the pesticides are staying on the landscape and not getting off. So in kind of conclusion, we have a lot of resources to help in understanding stormwater and water quality, identifying pests, and solving solving pest problems. We have the University of California statewide IPM website at ipm.ucanr.edu. We also, for pest identification, have a number of UC IPM books that will help you identify pests and find solutions. And so if you don't have access to the website, we have lots of books that are in the cooperative extension offices. And in our UC cooperative extension offices, which are in every county, we have advisors, and they have a great deal of knowledge on local issues. They may be an expert in soil, they may be an expert in water quality. We have a number of IPM advisors who are well-versed in pests and their management, as well as local pest pressures and different times of year. In addition to the advisors in the UC Cooperative Extension offices, we have a network of campus-based statewide specialists who also have a great deal of knowledge on pesticide issues, water quality, and we work together to try and help you solve your pest issues. Often associated with the cooperative extension offices is the local county ag commissioner. Many times they share an office or a hallway or just right next door. But even if they're not right next door, every county has a agricultural commissioner office, and they have biologists on staff that can help identify an issue and find solutions. And they often will work with the cooperative extension to make sure that your issues are being addressed. And also in the cooperative extension offices, we have our UC Master Gardener volunteers. And I know we have some UC Master Gardeners on the webinar today, and they are available to help identify pests and find solutions. And they use a lot of the UC IPM materials to help you find out about your pests. But I wanted to point out some resources on keeping our water clean and pesticides and water quality, since that is the topic that we're here to discuss today. So we have some information that is both on our website and available in print that we make available to the Master Gardeners and the UC Cooperative Extension offices on ways to keep your water clean. So a lot of what I talked about today, you know, narrowed down to these small cards, can help you if you are someone who discusses pesticides and water quality to folks, or if you yourself want to consider ways that you can reduce pesticides in the environment. And so we have just these quick bullet points and resources on our website to find more information, or resources outside of the UCIPM system, including the State Water Resource Control Board, various other state and local agencies that focus on keeping water clean and keeping pesticides from contaminating our waterways. So particularly on the UCIPM website, we have a section called Pesticides and Water Quality, where we break down very basic information on how pesticides are affecting water quality. What does that mean? What does it look like? And how do they get into our creeks and rivers? A lot of what I'm talking about today. And then these safer alternatives, such as using the other IPM components, the non-chemical components. So, it's really up to all of us to try and keep the pesticides where we put them and not have them run off to the unintended areas and affect our ecosystem. So we are ending a little earlier today, but if there are questions, I'm happy to do my best to answer them. Thank you.
Thank you, Karey, for that great talk. And thank you everyone for joining us today.